Hi, everybody. So does everybody know who these people are? No? Well, who's the lady on the left? Her name is Alicia Keys. What's she famous for? She's a 5-time Grammy Award-winning recording artist. And the people on the right are a little bit harder to guess. But they're a famous band from the 1980s called the Buggles. Yep, you nailed it. And they're famous for being the first music video aired on MTV. But today I'm going to convince you that they're more than just awesome recording artists. They're also code review visionaries. Okay? Okay. So my name is Shane McIntosh. I'm an assistant professor at McGill University, and I'm going to talk to you about some work that we've done on supporting and understanding modern code review. Okay? So before we get started, I know I'm in a room of people who don't really have my job. My job is different than your job. My job, unlike you, I take coffee and turn it into something other than code. I turn it into teaching resources, so I teach courses about software engineering and about software delivery. I turn it into research, which is why I'm here to tell you about some of the research that we do on code reviewing systems. And I also turn it into committee meetings that sound really fun for you guys. They're about as fun as you think they are. And I spend time in those places, trying to keep McGill running as a world-class university. Okay, but nowadays I'm an academic, but before that I wasn't always so respectable, right? So now I have a nice haircut and I look like I belong at a university, but before that I had a different haircut and I was a PhD student. Before that, I had shorter dreadlocks, and I was a software engineer at Dell EMC for 3 years. Before that, I had an even crazier haircut. I was a master's student. And before that, I had the dreadlocks again, but I was a rock star. And, yeah, maybe you want to hear some of my music? Yeah? Okay. That's what we're talking about, right? Yeah, so I used to play the drums like that. And now I do this. Okay. Maybe something went wrong. So nowadays, maybe that music helps you to understand why I named my research lab the Software Rebels. So Software Rebels is not just a cool name, it's an acronym for the kinds of research that we do in my group. So the RE in Rebels stands for repository excavation. So what does that mean? Well, what we do is kind of like what Luca and Cesare were talking about this morning. We take that development data that sits in archives and we turn it into something that is actively participating in your development process. So usually these things like your Jira repositories, your code review systems like Gerrit, your version control systems like Git, they accumulate a lot of data as you're developing your software, and they tend to sit around for archival purposes. They just sit on the shelf waiting for somebody to leaf back through them once in a while, maybe doing a root cause analysis and that sort of thing. What we do in my research group is we use that data and try and turn it into something that can help improve today's activities. So we use past activities to try to improve today's activities. So what does that look like? What do actual software rebels do? Well, some of them, like Chris, they use that data to mine bugs. So they try to understand the bugs of the past so that we can avoid them in the future. And what Chris works on is a type of research that we call just-in-time defect prediction. So what's just-in-time defect prediction? Well, it's the idea that if you know what risky commits of the past look like, the commits that introduced problems that leaked out to the field, for example, we can try and apply machine learning to that data and try and identify characteristics of those changes that we can use to predict the ones that will introduce problems like that in the future. Farida is a master's student who's doing stuff that maybe this community is more interested in. She's mining historical code review data to try to understand the benefits that people are gleaning from it. And one thing she's particularly focused on is code design. So how much code review discussion is about code design. And I'm going to talk a little bit more about what she's doing in depth. I also work with a Japanese PhD student named Toshiki, who I talked about at the last Gerrit Summit. So he's been working on this concept of contention. So code reviews that get really strong positive scores, but also get strong negative scores. And how do teams actually resolve that contention? So in a nutshell, what this aspect of our work, repository excavation, is about is trying to answer the question, what if your software repositories could talk? What would they say, and how would they help you to improve your development processes? So the BE in Rebels stands for build engineering. So in addition to mining this historical data, we also do work mining build systems and those sorts of things. So what do I mean by a build system? Well, we take a broader perspective than just talking about the build itself. We talk about the entire release pipeline. So that pipeline accepts patches as inputs, first integrates them into version control systems, then we execute a build process to turn it into something your customers want. Then we ship that new deliverable out to customers through deployment, and finally we monitor to generate insights for the next changes you're going to make. Now, all four of these steps in a modern release pipeline generate data and use a lot of data, and we try to incorporate that data and make it help for the different parts of the pipeline. So in the integration phase, that's where Gerrit falls. We can start to mine and produce plugins and introduce features to code review and different parts of the process that help developers do their jobs. So really what, in a nutshell, this area is about is data-driven decision support for modern release pipelines. And what do some of the rebels do who work in this area? So I have a PhD student named Kahelia who's working on tools that we call Hansel and Gretel. So Hansel and Gretel are tools that scan that YAML code that we heard all about this morning, specifically with respect to Travis CI, which is a cloud-based CI as a service provider. You configure Travis CI with a YAML file, but people make mistakes just like any other coding artifact when they're writing those YAML files. Hansel is a tool that will scan your Travis YAML file to catch anti-patterns, so security breaches and these sorts of mistakes. And Gretel is the one that will automatically propose fixes. So like any good brother-sister combo, the brother points out the problem and the girl does the hard work, right? Okay. Grown just like my students in my undergrad classes. That's a great joke. Okay. So Ray, who's here today, is a master's student, and he's worked on a broad spectrum of things. I talked about his work last year on studying how code review topics change over time. This year I'm going to talk about a different project that he worked on called BLIMP Tracer, which integrates build impact analysis into code reviewing interfaces. Finally, I work with a PhD student who's studying in Austria. His name is Chris Macho, and he's been studying how to automatically repair build breakage. So he has a tool chain that we call Build Medic. So just like a medic in a war scenario, this build medic will come in and automatically try to repair your build rather than having developers go and tweak things to make it pass. Okay, so in a nutshell, this is what the research group I direct works on. In the build engineering perspective, we talk about how we can leverage the pipeline to improve development and delivery practices. And altogether, that's what the rebels do. So one of the things that I'm hoping will come out of my visit here is that I start to establish more industrial collaboration links. And we'll talk more about kind of how we can do that work together at the end of the talk. Okay. But the focus of today's talk, I can't talk about what everybody's been working on. So I picked two topics that I think this community is probably most interested in. And that's two kind of studies we've done using code review or supporting code review. Okay? So I'm going to talk first about what Ray has been working on. And that's this tool called BLIMP Tracer. So this was a collaborative effort that we did with some colleagues at Dell EMC. Okay? And what is BLIMP Tracer? Well, it's a plug-in tool that's automatically scanning every new code change for product team at Dell EMC. So it scans about, these numbers aren't as impressive as some of the bigger groups, but it scans about 250 review requests for a software team at Dell EMC per month. Okay? And some characteristics of what that team is working on. So it's a development team that's composed of several sub-teams that are in different areas of the globe. So that includes a team in Canada, a team in China, a team in India, and a team in the US, here in the Silicon Valley. And what does the product do? Well, it manages backup and recovery for enterprise installations. Okay? So that software is made up of a traditional kind of client-server application. So you've got client software that gets installed on all the different machines that need to be backed up. You've got server software that kind of synchronizes the backups, controls them on a schedule, or these sorts of things. You've got administrator software that allows the administrator to set schedules and to manage the backup process. You've got storage node software that goes into the deep, ugly side of the back end that manages the actual data store area. And you've got modules for applications and databases, so things that would let you back up your SAP installations or your Oracle databases, these sorts of things. And that context is important for understanding why BLIMP Tracer was the appropriate solution for this team. So how does code review work at Dell EMC? Well, this probably looks familiar to a few of you, but the developers upload patches. They execute sanity tests automatically before code reviewers start looking at it to avoid having people pointing out kind of white space and boring stuff that bots could check. Then reviewers are notified and selected. The reviewers assess the patch, reviewing them, and then finally, after you make it through that process, the code change can be integrated into the version control system. Now, at any point in this process, if you fail a step, you go back to stage one and you iterate, okay? But the existence of a code review doesn't mean that you're going to achieve code quality. And we'll use this example of this really awesome developer here who's going to upload a change to Review Board, which is another code review system that was being used in this particular company. So he's going to upload a change to this SSL connection.c file. And we're going to take a closer look at the change. This looks familiar. It's the famous go-to-fail bug of 2016. Okay? So there's a clear error. There's no braces, so this go-to is always going to trigger. But there's going to be a really awesome code reviewer who's maybe not paying so much attention, and he just says ship it, right? It looks like a small change. What's going on? Just go ahead and ship it. Now, the question is, was this guy sleeping or what's going on, right? Well, it turns out he wasn't sleeping. He was doing a common practice that I think a few people in the room are familiar with. At least I'm familiar with it, called rubber stamping. When you get 10 review requests in the morning and you've got your own work to do, you don't have time to invest the amount of due diligence in every single patch. So you have to make a decision. Which patches are you going to invest your reviewing effort in, and which ones are you going to kind of skim through, right? So what this crafty developer is saying, I should focus my effort on the patches that I think are risky, the patches that are likely to introduce problems. So then now he's going to turn to Alicia Keys for some insight. Okay, so let's hear what Alicia has. Right? So some people think it's physical things that define what's within, right? So what's physical about a patch? Well, it's the size of the patch, right? So if we're going to assess risk, maybe we think riskiness is associated with how big the patch is, right? So if we ranked those 10 code review requests by how big they are, maybe this go-to-fail patch ranks pretty low in that risk assessment. And maybe that's why he just rubber stamped it, didn't check very carefully, okay? But Alicia has more insight for this code reviewer here, okay? So Right. So what Alicia is essentially saying here is that we should look beyond superficial things when we're performing our code review, right? And one of the ideas that we had was to look for the potential impact that the change has. Like, what parts of the product chain is it going to affect? And maybe that'll help us to assess the risk. Rather than just counting lines, maybe we can do something a little bit more productive. Okay, so let's go back to this go-to-fail example. What our idea is to inject a tool, we call this tool BLIMP Tracer, that's going to help you to rank the code reviews in your backlog by how big of an impact they have on the product suite, okay? But before we dove into that, we wanted to know how developers at the team were currently performing their code reviewing kind of ranking assessment stuff. And we wanted to know specifically how they perform impact analysis today. Like impact analysis is a kind of big area of research that stretches back to the 80s. It's been around for a long time, change impact analysis, but we didn't have a clear understanding of how impact analysis has been switched over to industry. Lots of papers, not sure about how it's done in industry. So what we did is we surveyed 16 developers on this team. What this slide is showing you is that about half of the people we interviewed are veteran members of the team. So it's not just the newbies who signed up for this survey. Okay. And what we found out was kind of surprising. So these are the popular ways that developers were performing impact analysis, so deciding what impact this change has on the different areas of the code base. And what jumps out immediately is that they use code search and especially just grep. So they're just grepping the source code to figure out which files call which other files. Another thing that jumps out is that they're doing a lot of this based on gut feeling that's been accumulated either by them or by expert gurus on the team. So if I change this file, I would go to the expert guru of that system and say, what does this impact, awesome developer guy. Now, there are a couple of problems with this. One is that understanding of the system is going to decay. So we know that systems change quite rapidly nowadays. And we have better tools than grep for doing code search nowadays. So we thought we can do better than this. What we really need for this specific setting is to extract that impact from an artifact that maintains information about impact. And for us, we decided to extract that information from the build system. The build system is where we maintain what depends on what and what gets bundled together into which deliverables. Okay, so our approach is kind of simple in that sense. So first we identify from a patch which files of the system have been changed. So we show those in yellow here. Imagine that example 1 and this example header file were changed. Then what we do is we construct a build dependency graph. Now, we have some tools for kind of doing this for make-based build systems that's called Macau. And they were using a make-based build system, so we could use Macau to extract the build dependency graph. And what Macau does is it's going to say, okay, this is what the build dependency graph looks like for this very tiny, purposefully artificial system, okay? And what we do, given this information, is we'll work backwards from the impacted files and kind of do a taint analysis. So which files are impacted and kind of do the transitive closure that way. So in this case, we would traverse back to these object files first, then we'd move up to the deliverables, and then to the phony target that maybe was impacted. Then we apply a filtering stage. So nobody cares that you're impacting intermediate files, and nobody cares that you're impacting the phony target at the top. What we really care about are the deliverables and which packages those belong to. Are you impacting the client software, the server software, the administrator workbench, et cetera, okay? And what we do after applying BLIMP Tracer is we built a plugin for the tool that they were using for code review that displays that information right in the code review interface. So the first comment that shows up on this code review here is that BLIMP Tracer detected the impact that the different files had. And if you want to see the details, you can click on it, and it takes you over to a dedicated page that gives you even more information. Okay? So next we wanted to know, okay, now we've got this tool, we've got it set up to automatically tag patches as they appear. What impact is this having on team members at Dell EMC? So for this, we recruited 5 participants in a one-on-one user study. And this slide just gives you some information about those participants. For privacy reasons, they're just named using alphabetical letters. Some of them are new developers, D and A are new developers, but the remainder have more than a decade of experience at Dell EMC, and some have even more than a decade of experience working on that specific project. Okay. So how did this study look? Well, we took those 5 participants and we created 3 kind of impact analysis questions for them. We created 3 patches, and we said, okay, use whatever technique you like to assess the impact that these patches have on the software system. You can use your favorite grep tool. You can use whatever you like, okay? Then we showed them BLIMP Tracer and asked them to assess the impact of the deliverables using that. And we transcribed and coded the results. So this was like a recorded user study. Afterwards, we went back and like transcribed that information, collected it, and analyzed it, okay? So what did we find? Some of the cool stuff, like quotes from the actual user study, were about BLIMP Tracer and its impact on the current practice of impact analysis at Dell EMC. So for example, some developers like A said it's impractical for them to use the tools that they're using now to assess impact for large files or large changes that impact several components, right? And B, C, and D said something along the lines of, we can only track immediately impacted components. You don't get the transitive closure that you would get using something like BLIMP Tracer, right? And C, D, and E said something along the lines that since BLIMP Tracer requires no manual input, like it's just a natural part of their workflow, it can accelerate the way they do their development. So some nice feedback for Ray. So BLIMP Tracer provides a more complete picture of the impact at no additional cost is kind of one way to summarize what we took away from that aspect. And another aspect was that reviewers are often unaware of the true impact that these patches have on the system. So they would make claims about impact based on their tools that were either incorrect or incomplete, right? So they're saying things like, although there are tools that analyze static structures, they don't actually use them every time they review code, which is probably natural. They're just going to apply them once in a while. And there are things that make BLIMP Tracers, BLIMP Tracer helpful in assessing deliverables, which can help them to actually do their testing more effectively. So if they know which products are affected by a change, they can now test more effectively. Another rather honest, brutally honest developer said he only assesses the impact of patches that he himself authors. So he didn't ever do impact analysis for patches that he reviews. But now that BLIMP Tracer is in place, he can do that automatically, right? So BLIMP Tracer is a natural fit for their workflow, and it helps them to kind of solve this problem of ranking patches for rubber stamping. I guess rubber stamping is the negative end. We should say it helps them to focus their effort on the patches that are likely to introduce risk. Okay. And I can't let Alicia Keys say all the setup and not give you the hook, right? So let's hear what she. Of course, the U she's talking about are risky patches, right? Grown again. Okay. But that's what I wanted to tell you about BLIMP Tracer. A few more pieces of information. If you're interested, which I hope you are, here's a QR code you can scan to get a free copy of the paper. Yeah, it's full of other awesome tidbits about how we implemented BLIMP Tracer, how we got it in. And I gave you kind of the positive aspects. There are also some feedback from developers that we use to improve BLIMP Tracer. But yeah. I think the slides will be available as well. Is that right? So you'll be able to get the QR code then as well. Okay, so that was a pitch for Ray. So Ray's work. Ray is also here, and he recently graduated. So if there are people in industry looking for a smart, hardworking kind of kid, he's back there smiling. Maybe give him a wave. There you go. I did your recruiting work for you. Okay. So the other aspect I wanted to talk about is the work that Farida did. So this piece of work that Ray did was kind of on the aspect of supporting code review. Farida's work is more about understanding what's actually happening during code review. And Farida's slides are a little bit more fun, I think. So let's have fun with Farida's stuff. So what she's doing is discussing, analyzing design discussions during code review. So what actually happens. So the first thing we usually do is discuss what code review means to us in our research context, and it's essentially a discussion. I think this audience is rather familiar with it. So if Farida here has uploaded a patch, a Python patch, and an awesome code reviewer comes along, highlights a problem, says maybe this could lead to a null pointer exception. Well, then what Farida would do, she'd upload a second patch that addresses the feedback, and then I'd come along and say, looks good to me, approved. Eventually, that means she can merge her patch. But nowadays, the code reviewing process isn't just person-to-person conversation, it's person-to-bot conversation as well. So bots are starting to take over, so they're coming along, and they can do that silly job of pointing out null pointer exceptions better than a reviewer can, right? So these guys actually caught a few spots where there were other types of exceptions that I didn't point out in my review, right? They can also catch silly white space issues, and they can run tests and these sorts of things, and incorporate all sorts of feedback that perhaps the reviewers are going to miss. So that's where these guys come in, the Buggles, and if you didn't recognize them before, I'm sure everybody knows what they're famous for, this song. And this song has got some insight about what this new bot-like world is like for reviewers, right? So automation's killing the code review star, right? Automation's taking over the code reviewer's job. How many people would agree with that? I think to some degree, code reviewers are spending less time doing the boring stuff. So code review is becoming less about pointing out the silly things that machines are better at doing, and it gives code reviewers actually more time to focus on higher level concepts, such as design or architecture. So in theory, nowadays, code reviewers should be spending more time talking about these higher level concepts. What we wanted to know is that actually happening in practice? So we needed a working definition of design before we would get in there, and we used a recent definition from a conference on mining software repositories where they analyzed whether developers are actually discussing design on IRC and these sorts of things. So what they define design as is the process of discussing the structure of the code, organizing abstractions, and their relationships. So we're going to use that definition to describe what design means for us. So a comment like this that's made by Toshki where he says, hey, Farida, I think you should place methods in a utility class so that they can be used by another module would be an example of a design-related code review comment, okay? And authors of patches maybe have different reactions to code, to design-related feedback, right? Maybe they don't care so much, but there's kind of a power shift, right? The reviewer is the one who decides whether your patch gets in, so she's not going to say this. She's going to say, of course, I'll do that. Thanks for the feedback. All your suggestions will be addressed. And we'll come back to that kind of dynamic a little bit later in the talk. So just to make sure it's clear, so we have comments like this that Toshki made that we would classify as a design-related comment. And then we have comments like tabs versus spaces, naming things, indexes out of range, no pointer exceptions, and other bot-related comments that we would classify as non-design-related feedback. Okay? So the questions we had was how frequently are developers discussing design? How much of what they're actually reviewing is considered design-related feedback? What are the types of design-related feedback that are actually happening? Can we automatically detect design-related feedback? And if we can do that, can we study the characteristics of patches that are associated with design-related feedback? Okay? And in order to perform our study, we needed some data, so we selected an open source project that's, I've learned recently, one of the bigger open source installations of Gerrit, right? And we picked two of the biggest projects on that Gerrit installation, which are Nova and Neutron, okay? And we picked it for various reasons, some of which are that they've heavily invested in bots in their code reviewing process. So there are a lot of bots in the Openstack code review process, and they're globally distributed, so that a lot of the design-related discussions should be happening on the code review process website rather than over water cooler discussions and these sorts of things. So we're expecting to see a lot of design-related feedback. So let's first dive into this discussion of frequency. So how often is design-related feedback happening? In order to answer this, unfortunately, we had to do a lot of manual work. So this means that we got our hands dirty. We took all the reviews of OpenStack. We extracted a random sample using some technology that's popular for polling. Maybe polling in political elections is not the most apt analogy to draw nowadays, but it's a type of technique that we use in qualitative research all the time, this random sampling thing. Okay, so we drew a random sample, and these two researchers, Farida and Toshki, did a manual classification on each review. So what they did, they'd read the whole review and they'd say, this review contains design discussion or it doesn't, okay? And since they did it independently of each other, we can compute how much agreement there is between them. So first of all, do people agree that there's a design discussion? Second of all, how often is it happening? Okay? So you end up with a classified sample. These are design, these are non-design reviews. And we repeated the process for Neutron. So we did it for Nova, and then we repeated the whole process for Neutron. Okay. And what did we end up seeing? Well, we first wanted to see of all the reviews, how many contain design. And the results were kind of interesting. They're consistent across the projects in that roughly 1 in every 3 reviews contained some design discussion, which is not too bad, right? But then when you look at a different perspective, how many design comments are there out of all the comments? The numbers drop quite low. So they're 9 to 14% of the comments that are generated. So that means that even if a review contains some design discussion, it's a needle in a haystack. There's still a lot of discussion about variable names and kind of white space problems and boring stuff. Okay? So what do we take away? Design comments are rare, but they are happening. And if you lift up to the appropriate level, maybe the numbers look okay to you. Okay. Next question we had was what kinds of things are being discussed? Design covers a broad spectrum of things. So what kinds of design are being discussed during OpenStack code review? And in order to do this, we did a lot more qualitative research, which means that we got our hands dirty again and actually read a lot of code review comments. So we'd take a code review, we'd extract the inline comments, and from the inline comments, we would see, we would classify them. So we applied a technique that's called open coding. So we didn't know what the categories were going to be. So that means we keep reading samples and classifying them until we achieve what we call saturation. Saturation means we haven't discovered any new categories for N reviews. And for us, N was 50. So they read a lot of reviews. And we assemble from that open coding process kind of a hierarchy of different types of reviewing comments. So let's take a look at some of the things they found. So this was the entire hierarchy, but let's also note that we kept track of whether an alternative solution was provided. So you can provide design feedback that just says your design sucks, or you can provide design feedback that says, did you consider an alternative approach? And that's a little bit more constructive, right? So we kept track of this Boolean. We'll call it alternative solution Boolean, okay? So the first category was this module coupling type of design, and an example of that would be something like this proposal, which was to have A create the X object separately from the Y object to keep Y and X objects from having any interaction with each other. So this is an example of this module coupling type of design discussion. And this we would label with the Boolean being true because they provided an alternative approach, right? So there were design discussions about performance. So they would say, they would propose an alternative solution that's maybe more efficient than this exponentially doubling algorithm that improves things for performance, from a performance perspective. And again, this alternative solution is true. They provided an alternative. Okay, so we also have this concept of a shallow fix. A shallow fix would be something that perhaps was fixed in one location but needed to be propagated to other areas of the code base. So something like this VIP port is, it's not too different from any other port, so it should be added to the X method of another plugin as well. Okay? We have side effects, so that would be things that maybe fix something in one location and break things in another one, like this hard coding breaks other hypervisors in the Openstack solution. But unfortunately, they're not providing an alternative here. They're just saying you're breaking stuff. Okay. There's the concept of unnecessary complexity. You're kind of reaching around your head and scratching this side. You could do it easier if you just reached up the other way. Here's an example where they're using table fetching. Why not directly query instead? And an alternative solution was provided. Code misplacement is another example where you've put a solution in one place where it could have been placed in another location to achieve the results a little more efficiently. And redundant code would be like duplicate code, copy pasting. Okay? So what did we notice about this hierarchy? One of the first things we took away was that a lot of this design discussion is happening because of a lack of awareness of global context of the code base. So you would have things like code misplacement. Maybe the author didn't know about where the proper placement of that code was. You have things like module coupling or shallow fix, which maybe indicate that the author wasn't aware of the global context of the code base that they were working within. So there are two sides to that coin. One is that code review is being a useful way of sharing information about the global context. The other side is that maybe there should be other things that other ways that people are discovering this rather than within the code review process. Another thing was we found that 73% of design-related comments were actually constructive, providing alternative solutions, which I think is pretty good. I don't have a baseline to compare that against, but it sounds like a pretty high number to me. So feedback to design issues is often quite constructive in the OpenStack context. But one negative aspect that we observed was that authors are rarely engaging in this design discussion. Often it's a one-way street. So only 10% of NOVA design discussions got an author to reply directly. Rather, they just do what the reviewer tells them to. And 20% in Neutron. So that brings back Farida's kind of thought. Maybe the author thinks, yeah, I don't agree with this, but they want to get their patch in, so they say thanks and just do it anyways, right? So authors are rarely engaging in a design discussion. So it doesn't really feel like a discussion. It feels more like a lecture, which maybe this feels like right now. Okay. So some things that we took away from this research, we got this nice hierarchy of design-related comments from the Openstack environment. What we observed from that hierarchy was that a lack of the awareness of the global context of the code base was often the driver for design-related feedback. Authors rarely respond, but the feedback is often very constructive. Okay, so now let's save Farida's life from doing this manual code reviewing stuff, and let's introduce some automatic stuff. Okay, so the question is, how accurately can we automatically identify design-related feedback? So to understand the motivation for this research question, let's shift back to what we did for RQ1 and 2, which was we had two very keen research students manually classify 220 reviews, which consisted of almost 3,000 comments. They did manual classification per review and per comment. But this sample of 3,000 comments is small compared to the entire population, which contains 2 million comments. And if I wanted them to manually classify that, the university ethics might have a problem with me. And Farida says, you know, maybe the supervisor killed the research student, right? Okay, so we don't want to do that. Instead, we want to introduce this little bot guy here who's going to learn from the code reviewing stuff that we did already. So we did all this work to manually classify almost 3,000 comments. We can feed that information into a machine learner that would figure out what design comments look like. Okay? So how does that work? Well, we do some natural language processing. It's kind of a typical NLP approach we applied. So we extract the comments. So for example, this comment, we apply kind of tokenization. So we turn it into a stream of tokens. We remove stop words, so the boring English words that don't contain much information. We stem those words. Then we feed that into a TF-IDF computation, which just turns the comments into vectors in the vector space. Then we did some over and under sampling. Because design comments are so rare, only 9 to 14% of the comments are design related. We have to do something to balance the categories. Otherwise, the classifier will just always say everything is not design. The reason is it'll get like 80% performance just by saying everything's not design, right? So we did some rebalancing to kind of get it to focus on design issues, okay? And then we feed all that information into a learner. We applied 5 different learners to train this little chippy guy, okay? So we used k-nearest neighbors, support vector machines, multinomial bayes, random forest, and decision trees, which are all kind of popular machine learning algorithms. And what those algorithms do is they classify things as either design-related or not design-related, okay? And what we found is that multinomial bayes tended to yield the best results. So just to make sure it's clear, so what this guy does, we take a comment we've never seen before, and it's going to classify them as either design-related or not design-related. And what we found is that this classifier achieved an AUC score, which I don't have time to explain. AUC, just think of it as a score between 0 and 1, 1 being perfect performance, 0.5 meaning it's as good as a random guess, like a coin flip, and 0 meaning it's completely incorrect all the time. So we got up to 85% performance, which is not too bad. So the answer to the research question is yes, it can be done. We recommend using MNB for this task. So what can we do with these automatically classified design and not design-related things? Well, we can start to study the characteristics of reviews that attract design-related feedback. And one thing that we noticed is that abandonment changes depending on whether there's design feedback or not. So there's a correlation between abandonment and design-related feedback. when you have design-related feedback, you tend to have more abandonment. And we did some statistical tests that indicate there's a significant difference there. So it's not just because of our sample, there's some actual difference going on. So what do you take away? Design-related code reviews are statistically significantly less likely to be accepted. Now, that may not be a bad thing. It may be that you're getting design-related feedback on an early version of a patch that you later resubmit after addressing the feedback, but at least there's some correlation between design-related feedback and abandonment. Okay. So what should we do about this? Well, we've known for a long time that poor design is related to a few things we want to avoid as an organization. So poor design leads to more rework, more wasted time, and more effort, according to Fowler since the refactoring book, and the Group of 4 Design Patterns book talks about that as well. So based on our feedback, we have some recommendations for organizations that do code reviews. They should encourage design-related feedback to be actually happening during the code reviewing process. We have bots to do the boring stuff now. I think it's time to start lifting the discussion up to the design and architecture level. What we believe is that if we do that, we'll increase within the team a global awareness of the code base. So we saw that design-related feedback was often caused by oversight in that process, so you don't really know about the different areas of the code base. You find out during code review. If we have more design-related discussions, maybe that knowledge-sharing process gets even better. And within the process of design-related code review, we have a question for future research, which is why isn't this really a two-way discussion? Right now, it seems like reviewers are just dictating design-related changes, and the authors make them happen. And it's very rare that authors re-engage in that process. One hypothesis is that there's that power dynamic. They want to get their patch in, so they just do whatever the reviewer boss tells them to. But I'd be interested in hearing what you guys think about that. Okay, so this is also a research paper that we recently published. It's got a bunch more interesting findings and all the nitty-gritty details of how we trained the models, how we applied that open coding process, and some really cool insights as well. So if you're interested, you can get a copy of that paper as well. Okay, so that was the focus of today's talk. I'm around for the rest of the conference, so I'm really interested in taking our research and applying it in industrial settings. So like we did with the BLIMP Tracer thing, we developed an analytics solution that was specific to the Dell EMC context. I believe that's the way that academics and industry should be working together, and I think we can both profit if we work together like that. So we've got current collaborations at the Rebels with Dell EMC, a company called Shopify, which is really big in Canada. I don't know how many of you guys know about Shopify here. And we've done some work with Sony Mobile in the past. Hopefully we can add your company here by the end of the day, and I can share a Ray with you, a future Ray with you, or a future Farida with you guys. Okay, so just to wrap up what I've been talking about, I told you about what my research group does. So we're the Software Rebels. We try to answer questions like, what if your software repositories could talk? And how can we leverage pipeline data to improve development and delivery processes? I told you about BLIMP Tracer, which is a tool we integrated into the Dell EMC development process, right into their code reviewing process. I told you about this analysis of code review design discussions where bots are taking over, and we suggest that this leaves more space for design-related discussion in the code reviewing process, but we had some observations about how much that's happening in Openstack's code base. We found that design is rare. This is Farida's emoji-style conclusion, which is pretty cute. Authors are quiet in the design discussion. Feedback is constructive, but code review is actually a nice way to share knowledge about the design. So there's some knowledge transfer that's happening during design-related code reviews. So again, my name's Shane. I'm a prof from McGill University in Montreal, and my contact info is there, so let's stay in touch.
A subject that you just touched very lightly at the beginning of your introduction, very interesting, thank you for that. You used the words risky commits. So that's one thing that we're very much interested in. So I'm going to ask you, how do you quantify the risk of a commit? Do you have a score system? What gets into that score? Can you expand on that, please?
Yeah, so what we did with BLIMP Tracer was we assessed risk for Dell EMC by saying there are particular products that are used by more customers than other products. So a change that impacts a deliverable that's used by a lot of customers was one way of assessing the risk. But what we talk about in the just-in-time defect prediction, which I think is the one you're talking about, is we assess risk by backtracing from bugs. So we assume that a bug fix implies that a bug was somewhere before the fix was applied. So that means if we trace back from the fix, we can trace the lines that were involved in the fix back to when they got introduced. And through some kind of heuristics, we assume that some of the lines that were fixed actually introduced the problem initially. And then we can try and apply those same machine learning techniques to predict those changes that will introduce risky lines that are implicated in future bug fixes.
I believe BLIMP Tracer is really cool, but it is not integrated with Gerrit. My understanding, yeah. So, and I believe it will be great for us to have something like that integrated and start doing some dog fooding with Gerrit. Do you have any plan to integrate BLIMP Tracer with Gerrit Code Review and not Preview Board?
So a part of the thing that makes my job interesting and also kind of frustrating is that my employees are by nature very short. So Ray has graduated already, and he developed BLIMP Tracer as part of his master's thesis. He would be a great guy to actually do the port to Gerrit, but he's no longer my employee. So maybe if I find a future student, it would be good. Or we can rope Ray into the Gerrit community and get him to do that in his time.
Another option is as well, if the code is available anywhere and he is willing to sign the Google CLA, then he will be able to do at least the first push into Gerrit review, and then the entire community can take over.
Sounds good to me. I don't know. Maybe Ray wants to weigh in. What do you think, Ray?
Do you have any data on how development culture affects the results of your study?
So for the BLIMP Tracer example or for the software design? Okay, so for BLIMP Tracer, yeah, there's some development culture that I'm sure is affecting that. Like we did the study of how developers at Dell EMC are doing impact analysis. My hunch is that developers aren't really using the research tools that we produce. And I think that it's not fair to blame developers for that. We don't do a good job of making them available. So I think the project that we did at Dell EMC was to actually integrate the tools seamlessly into the way that they do their process. I don't know how you guys feel about it, but I feel like a lot of people still use grep to figure out impact analysis. Maybe it's different at Google or at Facebook or maybe some of the bigger places that have an in-house research lab. Maybe they're integrating tools in their processes. But from what I've seen, I feel like that transfers pretty well. Now for the design discussion, yeah, I'd be really interested to see that. So obviously I can't claim anything general about what we did. It was really specific to Openstack, but it was consistent across Openstack projects. Like a kind of high level 1 out of 3 and then a low level kind of 1 out of 10 in a few of the OpenStack projects. Do you think there are companies that have better design discussion? Do you think that somehow correlates with the way that the company culture is? Yeah? I think, yeah. Yeah, there could be some aspect of that, right? Like, I feel like if people buy into the value of code review, they're more willing to invest in actually doing code review well, right?
Yeah, I feel your research is very valuable because it's a good selling point to change development culture. So thank you.